these properties we study in physical optics. According to physical optics, here according to Huygens scientists, light propagates in the form of waves. We are considering wave nature of light. From that only we study the properties of light rays. What are that? Interference, diffraction and polarization. Now, here we have in physical optics or wave optics. Physical optics or wave optics. Ray optics is called what? Ray optics or geometrical optics. Here physical optics or wave optics. Now, in this we study about electromagnetic wave, wavefront Huygens principle, and also reflection of light based on Huygens principle, and also refraction of light based on Huygens principle, and behavior of wavefront in a mirror, lens, prism, coherent sources, interference, Young's double slit experiment and colors of thin films. Now, here first of all we discuss electromagnetic wave. Here you know that light rays are nothing but what? Electromagnetic waves. Light rays are electromagnetic waves. Now, in electromagnetic wave what happened? Here electric field vector, magnetic field vector. E naught represents what? E represents what? Electric field, intensity of electric field. B represents what? Magnetic induction field. Now, E naught is the maximum value of intensity of electric field. B naught is the maximum value of magnetic induction field. Now, here electromagnetic wave means what? Here electric field vector vibrating, here magnetic field vector vibrating. Suppose here electric field vector vibrating along negative y axis, magnetic field vector vibrating along z axis, then electromagnetic wave is propagating along x axis. Here now in electromagnetic wave what happened? Variations in both electric and magnetic field occur simultaneously here, and therefore they attain their maximum and minimas at the same place at the same time. Here it has electric field is maximum, magnetic induction field is maximum. Here electric field is minimum, magnetic field is minimum, like that. Now, here electric field is along suppose electric field is along y axis, magnetic field is along z axis, then electromagnetic wave is along electromagnetic wave propagating along x axis, like that. Here direction of electric and magnetic fields are mutually perpendicular to each other. Here already I told that if the electric field vector vibrating y axis, magnetic field vector vibrating z axis, like that. Here the direction of electric and magnetic fields are mutually perpendicular to each other, as well as direction of propagation of wave. Here electromagnetic wave is propagating perpendicular to the here electric field and magnetic field. X axis is perpendicular to y axis and x axis is perpendicular to z axis, and y and z axis also perpendicular. And here speed of electric field, speed of electromagnetic wave depends entirely on the electric and magnetic properties of medium in which wave travels, and not on the amplitude of their variations. Now, wave is propagating along x axis with speed of much 1 by under root of mu naught epsilon naught. C is equal to 1 by under root of mu naught epsilon naught. What is mu naught? Mu naught is permeability of free space. Mu naught value how much? Here epsilon 0. Here mu naught is permeability of free space. Its value is 4 pi into 10 to the power of minus 7. Here epsilon 0 how much? Here 8.85 into 10 to the power of minus 12. Here mu naught how much? Here 4 pi into 10 to the power of minus 7. Epsilon 0 value how much? 8.85 into 10 to the power of minus 12. If I are substituting this, we are getting C value 3 into 10 to the power of 8 meter per second. Here anyhow speed of electromagnetic wave depends on what? Here depends entirely on the what? Electric and magnetic properties of medium. Here what is mu naught? Mu naught is permeability of free space. Mu naught represents what? Permeability of free space. Here epsilon 0 represents what? 8.85 into 10 to the power of minus 12. Substituting these values, we are getting speed of light how much? 3 into 10 to the power of 8 meter per second in air or vacuum. Here electromagnetic wave means what? Light rays are nothing but what? Electromagnetic waves. Here electric field vector vibrating, magnetic field vector vibrating. But here electric field vector vibrating is more. Here we have more significance. For discussion of optical property of electromagnetic wave, more significance is given by the electric field. Therefore, electric field vector is called what? Light vector. Electric field vector is called what? Light vector. We have more significance. Now, is it clear? Here light rays are nothing but electromagnetic waves. In this electromagnetic wave, electric field vector vibrates, magnetic field vector vibrates, but electric field vector vibrations are more. Here we have more significance. Here light rays, కాంతి కిరణాలు అనేవి ఏంటి? విద్యుదయస్కాంత తరంగాలు. ఎలక్ట్రోమాగ్నెటిక్ వేవ్, ఎలక్ట్రోమాగ్నెటిక్ వేవ్ అంటే ఏంటి? విద్యుదయస్కాంత తరంగాలు. ఇక్కడ కాంతి కిరణము, కాంతి, ఇక్కడ ఎలక్ట్రోమాగ్నెటిక్ వేవ్ మీన్స్ వాట్? విద్యుదయస్కాంత తరంగాలు. కాంతి తరంగ రూపంలో ప్రయాణిస్తుంది. కాంతి తరంగాలు ఏంటి? అవి విద్యుదయస్కాంత తరంగాలు. ఈ విద్యుదయస్కాంత తరంగాల్లో ఇక్కడ విద్యుత్ క్షేత్ర తీవ్రత, అయస్కాంత క్షేత్ర తీవ్రత మారుతూ ఉంటుంది. ఒక ప్రదేశంలో ఒక పర్టికులర్ పాయింట్ వద్ద ఇక్కడ ఒకే ప్రదేశం వద్ద ఎలక్ట్రిక్ ఫీల్డ్ వెక్టార్ అంటే విద్యుదయస్కాంత క్షేత్ర తీవ్రత, విద్యుత్ క్షేత్ర తీవ్రత, అయస్కాంత క్షేత్ర తీవ్రత రెండు మ్యాక్సిమం వాల్యూ, గరిష్ట విలువలను, కనిష్ట విలువలను కలిగి ఉంటాయి. ఇక్కడ మనకు స్పీడ్ ఆఫ్ లైట్, కాంతి వేగం ఎంత మనకు గాల్లో? 3 × 10⁸ మీటర్ పర్ సెకండ్. అయితే ఇక్కడ విద్యుత్ క్షేత్ర తీవ్రత, ఇక్కడ వేరియేషన్స్, విద్యుత్ క్షేత్ర తీవ్రత, ఈ మనం ఎలక్ట్రోమాగ్నెటిక్ వేవ్ని డిస్కస్ చేసేటప్పుడు, మనం ఆప్టికల్ ప్రాపర్టీ ఆఫ్ ఎలక్ట్రోమాగ్నెటిక్ వేవ్ ప్రాపర్టీ డిస్కస్ చేసినప్పుడు మనకి హియర్ మోర్ సిగ్నిఫికెన్స్ ఈజ్ గివెన్ బై వాట్? ఎలక్ట్రిక్ ఫీల్డ్ వెక్టార్. అంటే విద్యుత్ క్షేత్ర తీవ్రత మనకి ఎక్కువ సిగ్నిఫికెన్స్ చూపిస్తుంది. అందువల్ల విద్యుత్ క్షేత్ర తీవ్రతనే మనం లైట్ వెక్టార్ అంటాం. అంటే కాంతి సదిశ, కాంతి సదిశ అంటే విద్యుదయస్కాంత క్షేత్ర తీవ్రత. లైక్ దట్. నెక్స్ట్ వన్ we have wavefront. What is that wavefront? Wavefront is the point of disturbance due to propagation of light. If the light propagates on the time, here wavelet is the point of disturbance. Wavelet is the point of disturbance due to propagation of light. Here what is wavefront? Wavefront is the locus of points having same phase of oscillations. What is wavefront? Locus of all points. Locus of points having the same phase of oscillations. Phase is same. Phase is same. A line perpendicular to wavefront is called what? Ray. If you take spherical wavefront, here if you take point source, if you take a source of light, point source of light, we are getting spherical wavefront. Now a line perpendicular to wavefront is called what? Ray. Now these red lines represents what? Rays, light rays. Now here these pink dots represents what? Pink circles, pink spheres represents what? Here wavelets. Here now these are here circles, spherical shape that are called what? Wavefronts. Here what is wavefront? A wavefront is a locus of points having the same phase of oscillations. Here suppose here every point on the wavefront has same phase. What is phase difference? Phase difference between the 2 points on the wavefront how much? 0. Conceptual question. You remember this. What is phase? What is wavefront? Wavefront is the locus of points having the same phase of oscillations. Having the same phase of oscillations. Means what? Locus of all points which are in same phase. Locus of all points which are in same phase. ఇక్కడ మనకి ఈ వేవ్ ఫ్రంట్ మీద మనకు ఇక్కడ ప్రతి పార్టికల్ అక్కడ మనకు అన్నీ ఒకే ఫేజ్లో ఉంటాయి. అందువల్ల ఫేజ్ డిఫరెన్స్ ఎంత అవుతుంది? 0 అవుతుంది. అలానే లీనియర్ సోర్స్, ఈ లీనియర్ సోర్స్ తీసుకుంటే మనకి ఏమొస్తుంది? సిలిండ్రికల్ వేవ్ ఫ్రంట్ వస్తుంది. లీనియర్ సోర్స్ తీసుకుంటే మనకు సిలిండ్రికల్ వేవ్ ఫ్రంట్ వస్తుంది. నెక్స్ట్ వన్ ప్లేన్ వేవ్ ఫ్రంట్. హియర్ ప్లేన్ వేవ్ ఫ్రంట్, ది spherical or cylindrical wave front observed from the distant object. On the time the spherical wave front becomes what? Plane wave front. Like that. Here plane wave front. Here pink dots. Here wavelets, blue envelope. What is that? Wave fronts. Red lines represents what? Rays. Like that. And now Huygens construction or Huygens principle of secondary wavelets. Here according to Huygens scientist, here if you take a point source of light, we are getting spherical wave front. Now spherical wave front. Here so this wave front means what? Already I told that locus of all points which are in same phase. Now according to Huygens scientist, every point on the wave front acts as a source of secondary wavelets, acts as fresh source of disturbance of light. Here every point on the wave front, suppose this is the primary wave front. Here on the primary wave front, every point on the primary wave front acts as a source of secondary wavelets. And here if we know the time, we calculate the position of secondary wave front. Here how we calculate now? Here according to Huygens scientist, now suppose this is the point source of light, we are getting wavefront. This is wavefront. Now every point on the wavefront acts as a source of secondary wavelets, like this. We are getting secondary wavelets. Now in time t seconds, how much distance travels here? S is equal to what? Here c into t. So again we calculate secondary wavefront. If you know the time, if you know the position of primary wavefront, we calculate position of secondary wavefront. If you know the position of primary wavefront, we calculate position of secondary wavefront, like that. Here, that only given here, each point on the wavefront acts as a fresh source of disturbance of light. So everything, every point on the wavefront acts as a source of what? Secondary wavelet. This is new source, like that. And new wavefront at any time later is obtained by taking the forward envelope of all the secondary wavelets at that time, like that. We draw a here, if you know time, distance is equal to what? Speed into time. Here, if you know the time, if you know primary wavefront, we calculate position of secondary wavefront. Position of secondary wavefront. Here, we have one question. Backward wavefront is rejected. Why? What is the reason? Amplitude of secondary wavelets is proportional to what? 1 by 2 into 1 plus cos theta. Obviously, for the backward wavelet, theta is 180 degrees. Cos 180 how much? Minus 1. 1 minus 1 how much? 0. That's why we are not getting here backward wavefront is rejected. So always we are getting wavefronts in forward direction. We are getting wavefronts in forward direction. Now here new wavefront. Suppose after some time, after long time, we are getting wavefront reaches here, spherical wavefront. But from with respect to the source, this it appears to be what? Plane wavefront. Here spherical wavefront only, from for distant object it appears to be what? Plane. Now this is point source of light produces what? Spherical wavefront. If the distance is increases, if the distance after a long time, here we are getting that spherical wavefront appears to be plane wavefront. Spherical wavefront appears to be what? Plane wavefront, like that. Next one, here loss of reflection at a plane surface. Now, the Huygens scientist, here according to we have loss of reflection. What is loss of reflection? Angle of incidence is equal to angle of reflection. Now that here you already studied, reflection means what? Bounces back. Now these are incident rays, these are reflected rays. Reflection means what? It reflects into the same medium, bounces back. Now this phenomena is explained by Huygens scientist with the help of what? Wave theory. Now here also here AB is incident wavefront. AB is incident wavefront, CD is reflected wavefront. Now XY is the reflecting surface. XY is the reflecting surface. Anyhow, here we are getting angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Here, so already you know that here loss of reflection. You know in ray optics you already studied. What you studied? Reflection, loss of reflection. What is loss of reflection? Angle of incidence is equal to what? Angle of reflection. So that only explained with the help of wave theory of light. So anyhow, angle of incidence is equal to what? Angle of reflection. Next one, loss of refraction. Same thing here also. According to Snell's law, what is that? Mu is equal to sin I by sin R. Mu is equal to what? Sin I by sin R. Here that only refraction. If a light ray travels from one medium to other medium, it bends at the interface operating two media. Here suppose AB is the incident wavefront, CD is the refracted wavefront. On the time, here light ray travels from rarer medium to denser medium, it bends towards the normal. It bends towards the normal. Here that only, here Snell's law, loss of refraction, sine of angle of incidence is directly proportional to what? Sine of angle of refraction. So now, so that only explained with the help of wave theory. Now anyhow mu is equal to what? Sin I by sin R. Mu is equal to sin I by sin R. Same formulas in ray optics you already studied. Now you remember this formula, that only. But what is difference here? Huygens scientist explained laws of refraction at a plane surface on a Huygens principle. On Huygens principle, laws of refraction you already studied. Now mu is equal to what? Sin I by sin R. Next one, here. Next we have coherent sources. We have coherent sources. What are coherent sources? Here coherent source of light are those sources of light which emit light waves of same wavelength, same frequency and in same phase or constant phase difference. Here two light sources produces light waves of same wavelength, same frequency and in same phase or constant phase difference. ఇక్కడ two sources produce చేసేటటువంటి ఈ waves కాంతి తరంగాలకు తరంగ దైర్ఘ్యము, పౌనపున్యము, ఫేజ్. ఇక్కడ ఈ ఫేజ్ డిఫరెన్స్ అనేది కాన్స్టెంట్గా ఉండాలి. ఉంటే ఆ సోర్సెస్ని ఏమంటాం మనం? కోహరెంట్ సోర్సెస్ అంటాం. ఇస్ ఇట్ క్లియర్ నౌ? వాట్ ఆర్ కోహరెంట్ సోర్సెస్? Coherent source of light are those source of light which emits lights of same wavelength, same frequency, same phase, or having constant phase difference. Phase difference constant ga untundi. How we produce coherent sources? Coherent sources can be produced by two methods. First one, by division of wavefront, Young's double slit experiment funnels by prism and Lloyd's here mirror. Now by division of wavefront and by division of amplitude, partial refraction or refraction. Here by division of wavefront is divided into two parts. We are getting two sources are illuminated with what? One source. On the time we are getting two sources are illuminated with what? One source. On the time the two sources are acts as what? Coherent sources, like that. With the help of here only one wavefront. Here two sources are illuminated with one wavefront. On the time the two sources acts as what? Coherent sources. And by division of amplitude, here partial refraction and a refraction. Next one, here interference of waves. Now interference, what is interference? Here two light waves. Here what is interference? It is property, interference is nothing but property of light rays. So what is that? Here phenomena of one wave interfering with another and the resulting redistribution of energy in the space around the two sources of disturbance. If two sources are superimposed, here one wave interfering with the other wave, on that time what happened? Resulting redistribution of energy in the space around the source of distribution. If two waves are superimposed, what happened? Total energy is redistributed. Means what? Variation in the intensity in the region of superposition of light waves. So what is interference? Variation in the intensity in the region of superposition of light waves. Now two light waves are superimposed. Or interfered. On that time we are getting, sometimes we are getting maximum intensity, sometimes we are getting minimum intensity. Sometimes we are getting dark band, sometimes we are getting bright band. Now at bright band we have more intensity. At dark band we have less intensity. Now anyhow, redistribution of energy. Total energy is redistributed. At some places we are getting bright band, sometimes places we are getting dark band. So that is called what? That phenomena is called what? Interference. Now interference of waves. Here we have red is one wave and violet is one wave. Now these two waves are superimposed. Now both are in same phase. We are getting more maximum amplitude. Here what we are getting? Maximum amplitude, maximum energy and maximum intensity. Here same phase. Phase means what? It describes state and position of a particle. Phase means what? It describes state and position of a particle. Now two waves are propagating with the same phase. Here we have two waves, one is red and violet. On the time these two are superimposed. Now amplitudes are same phase. Amplitude is vector. So amplitude becomes what? More. Here like that. Here, so both are in same phase. In phase, we are getting how much constructive interference? Energy becomes what? E1 plus E2, like that. And destructive interference, these two are out of phase. First wave is traveling positive x-axis, second wave is traveling negative x-axis. Here first wave is traveling along positive axis, second wave is traveling along negative axis. On the time both are out of phase. Here amplitude becomes what? A1 minus A2. So energy becomes what? E1 minus E2. Intensity proportional to what? Square of amplitude. Now otherwise here we are taking E1, E2 or amplitudes. Here we take E1, E2 or amplitudes. Here amplitude becomes what? E1 plus E2. Here amplitude becomes what? E1 minus E2. E1, E2 or amplitude. These two are out of phase. Here opposite direction. Two vectors are opposite in direction. What we do? E1 minus E2. Two vectors are in same direction. E1 plus E2. This is constructive interference. This is destructive interference. Now here, now green color indicates what? This is the resultant wave. Two waves are superimposed, interfere, we are getting resultant wave. Now that only interference. Now suppose we have two sources. Now this interference phenomena explained by Young's double slit, Young scientist with the help of Young's double slit experiment. We discussed that. Now in that Young's double slit experiment only we are getting this. Again I explain now. Next one. Now theory of interference of waves. Theory of interference of waves. First of all I explain now theory, after that first I explain interference phenomena, after that theory of interference waves. Here now we discuss Young's double slit experiment, after that theory of Young's double slit experiment. Now in Young's double slit experiment what we have, first of all here we take single slit, that single slit is illuminated with source of light. On that time we are keeping two more slits, we take one more slit, it has two slits. Now the two slits are illuminated with what? Single source of light, single slit. On that time here these two sources acts as what? Coherent sources. These two sources acts as what? Coherent sources. From these two sources we are getting coherent waves. That coherent waves are superimposed. That coherent waves are superimposed. On the time now we are keeping screen. Now on the time on the screen we are getting dark bands and bright bands. How we are getting dark bands and bright bands? Here from two sources we are getting two coherent waves. Here according to Huygens scientists, light waves are transverse in nature. Light waves are transverse in nature. Now కాంతి కిరణాలు అనేవి ఇక్కడ తిరియక్ తరంగాలు. ఇక్కడ మనకి మనం యంగ్స్ డబుల్ స్లిట్ ఎక్స్పెరిమెంట్, ఇక్కడ మనకి ఈ టూ స్లిట్స్ని ఏం చేస్తాం, మనం ఒక స్లిట్ ద్వారా ఇల్యూమినేట్ చేస్తాం. అంటే వీ హ్యావ్ ఓన్లీ వన్ పాయింట్ సోర్స్ ఆఫ్ లైట్. ఫ్రమ్ పాయింట్ సోర్స్ ఆఫ్ లైట్ వీఆర్ గెటింగ్ light. Now with the help of this light we illuminate these two slits. Now these two slits act as two coherent sources. Now from these two coherent sources we are getting two coherent waves. From these two slits we are getting what? From two sources acts as what? Coherent sources. Now from these two coherent sources we are getting two light waves. That two light waves are superimposed. That two light waves are superimposed like this. This is one source S1, this is one source, one more source S2. We are getting like this. Here now when we are getting maximum intensity, when bright band will form, crest of one wave. Is it clear now? Young's double slit experiment. Now this is the screen. Here we observe bright bands and dark bands. Bright bands and dark bands. Now here look here. Now from these two sources we are getting two coherent waves. Here now transverse waves. Transverse wave means what? We have crests and troughs. Here crest of one wave overlaps the crest of other wave, or trough of one wave overlaps the trough of other wave. On that time bright band will form, we are getting maximum intensity. Crest of one wave overlaps the crest of other wave, trough of one wave overlaps the trough of other wave. We are getting these two are in phase. Crest of one wave overlaps the crest of other wave, both are in phase. We are getting maximum intensity. We are getting maximum intensity. Otherwise crest of one wave overlaps the trough of other wave, we are getting trough of one wave overlaps the trough of other wave, they are also in phase. We are getting maximum amplitude, maximum intensity, bright band will form. That is called what? Constructive interference. Constructive interference. Otherwise crest of one wave overlaps the trough of other wave, crest of one wave overlaps the trough of other wave, they are out of phase. On that time dark band will form. Here now these are crests, troughs, and red line indicates what? Bright bands. Now dark line, block line indicates what? Dark bands. Here from two sources we are getting transverse waves. Now in transverse waves means what? We have crests and troughs. శృంగాలు ద్రోణులు ఉంటాయి. ఒక తరంగంలో శృంగం ఇంకో తరంగంలో శృంగం కలిసిన, ఒక తరంగంలో ద్రోణి ఇంకో తరంగంలో ద్రోణి కలిసిన మనకి ఈ యాంప్లిట్యూడ్ ఎక్కువ అవుతుంది, మనకు ఇంటెన్సిటీ ఎక్కువ అవుతుంది, అప్పుడు బ్రైట్ బ్యాండ్ ఫామ్ అవుతుంది. దట్ ఈస్ కాల్డ్ కన్స్ట్రక్టివ్ ఇంటర్ఫిరెన్స్. అదర్వైజ్ crest of one wave overlaps the trough of other wave. Crest of one wave overlaps the trough of other wave. So on that time these two are out. Crest of one wave overlaps trough of other wave. These two are out of phase. So on that time amplitude is minimum and intensity is minimum. We are getting dark band like this. Is it clear? Interference means what? Variation in the intensity. If two waves are superimposed, two waves are interfere. From two sources we are getting two waves. From two sources we are getting two waves. Now these are overlaps. Here these two are interfere, superimposed. On that time crest of one wave overlaps the crest of other wave, or trough of one wave overlaps the trough of other wave. So on that time here these two are in phase, we are getting maximum amplitude, maximum intensity, bright band will form, that is called what? Constructive interference. Otherwise crest of one wave overlaps the trough of other wave, these two are out of phase. So on that time destructive dark band will form, that is called what? Destructive interference. If two waves are out of phase, destructive interference, both are in phase, constructive interference, like that. Now theory of interference of waves. Here already explained, from two sources we are getting two waves. From two sources we are getting two waves. Now E1, E2, what are E1, E2 here? Displacements. E1, E2 represents what? Displacements. Now E1 is equal to A sin omega t. What is E2? E2 is equal to what? B sin omega t plus pi. Here what is E here? Here E1, E2 are instantaneous values of electrical displacements. Light rays are nothing but what? Electromagnetic waves here. So it are nothing but what? Instantaneous values of electric displacements. Here in our textbooks y is equal to what? Y1 plus y2. So actually we are taking displacements. Actually that are electrical displacements. Now here E1 is equal to what? A sin omega t. What is A? Amplitude. Omega angular velocity, t time. Here E2 same instantaneous displacement. B means what? Amplitude, omega angular velocity, pi is phase. Now here that waves are with same speed, wavelength, frequency, time period, nearly equal amplitude, traveling in the same direction with constant phase difference pi. Here these two waves, now these two waves having same speed, omega, same speed, wavelength and frequency, time period. Omega is same. Omega is same is what? Frequency same, time period is same, like that. Nearly equal amplitude, A and B also nearly equal amplitude, traveling in same direction with constant phase difference how much? Pi. On that time what is omega? Omega is called what? Angular frequency of the waves. A and B are amplitudes. E1, what are E1, E2? E1, E2 are instantaneous values of electrical displacement. Now applying superposition principle, applying principle of superposition or superposition principle, magnitude of resultant displacement, magnitude of resultant displacement how much? E is equal to what? E1 plus E2. E1 how much? A sin omega t, E2 how much? B sin omega t plus pi. Now here sin omega t plus pi, sin omega t plus pi how much? Sin A plus B, sin A cos B plus cos A sin B. From this here we are getting, we have E is equal to how much? E1 plus E2. E is equal to E1 plus E2. Now from this here E is equal to E1 plus E2. From this E1 value how much? A sin omega t. B how much? E2 how much? B into sin omega t plus pi. Here sin A plus B. Sin A plus B how much? Sin A. Here E is equal to A sin omega t. Sin A plus B how much? Sin A cos B plus cos A sin B. So B into sin omega t cos pi plus B cos pi, B cos omega t sin pi. Sin A plus B, sin A cos B plus cos A sin B. From this E is equal to what we take common now? Sin omega t we take common. What we are getting now? A plus B cos pi into what we are getting now? Sin omega t plus here B sin pi cos omega t. B sin pi cos omega t, that only here. Plus B cos pi sin omega t we take common plus B sin pi cos omega t. Now putting A plus B cos pi is equal to what we take? A cos theta. Here B sin pi is equal to what? A sin theta. Now substituting these values, what we are getting? E is equal to A into sin omega t plus theta. Again if we are substituting these values, again we are getting what is that? Sin omega t cos theta plus cos omega t sin theta. So E is equal to how much? A into sin omega t plus theta. What is E here? E is the resultant displacement. E is the resultant displacement. What is A? A is the resultant amplitude, theta is the resultant phase difference. Resultant phase difference. Here I think in our textbooks they took Y. Y is the displacement. Actually light waves are electromagnetic waves. So these are nothing but what? Electrical displacements. These are nothing but what? Electrical displacements. Now resultant electric displacement how much? Resultant wave displacement how much? E is equal to what? A sin omega t plus theta. E is equal to what? A sin omega t plus theta. What is A? Resultant amplitude. E is what is E? Resultant displacement. What is theta? Here resultant phase difference. Now, how we calculate resultant amplitude here? Resultant amplitude. How much here? Here under root of here resultant amplitude a square squaring and adding a square cos square theta plus a square sin square theta, squaring and adding here a cos theta whole square plus a sin theta whole square. Here we are getting, here we know a cos theta, a sin theta, squaring and adding equation, these two equations, a cos theta, a sin theta, a square sin square theta plus a square cos square theta. If I are doing like that, here a square sin square theta plus a square cos square theta is equal to what we are getting now, b sin pi whole square, b sin pi whole square plus a plus b cos pi whole square. From this, here we take a square common, a square we take common, what we are getting, sin square theta plus cos square theta. Here what we are getting now, a plus b cos pi or b square sin square pi plus a square cos square pi plus b square cos square pi plus 2ab cos pi, 2ab cos pi. From this, here sin square theta plus cos square theta how much? 1. So, a square into 1 is equal to, here we take a square common, a square we take common, here we take not a square, b square we take common. Here what we have now, b square, here what we have now, b square cos sin square pi plus b square cos square pi. We take b square common, what we are getting now, sin square pi plus cos square pi plus a square cos square pi plus 2ab cos pi. Here we are getting, what we are getting now, here b square sin square pi plus cos square pi how much? Here it is a square only, a plus b cos pi. So, we are getting here a plus b whole square. So, a square. Now, b square plus a square plus 2ab cos pi, 2ab cos pi. From this, sin square pi plus cos square pi how much? Sin square pi plus cos square pi is 1. So, what we are getting, a square plus b square plus 2ab cos pi. Take square root on both sides, what we are getting, a is equal to how much? Under root of a square plus b square plus 2ab cos pi. A is equal to how much? Under root of a square plus b square plus 2ab cos pi. What is pi? Pi is the phase difference between two waves. Pi represents what? Phase difference between two waves. What is theta? Resultant angle. Here angle made by the resultant with a, resultant wave. Tan theta is equal to what? B sin pi by, yes, sin theta by cos theta, tan theta. A sin theta by a cos theta. Tan theta is equal to what? B sin pi by a plus b cos pi. Tan theta value how much? B sin pi by a plus b cos pi. What is theta here? Resultant direction. Here direction of resultant wave. Direction of resultant wave with first wave. Here we have two waves, E1 and E2. Now, direction of resultant wave with the first wave, like that. Is it clear? So, depends on these we have problems. Here, what is resultant amplitude? Under root of a square plus b square plus 2ab cos pi. Resultant amplitude how much? Under root of a square plus b square plus 2ab cos pi. And direction of resultant wave how much? B sin pi by a plus b cos pi, like that. And next we have, is it clear now? Now, a is under root of a square plus b square plus 2ab cos pi. Now, intensity proportional to what? Square of amplitude. In waves chapter you already studied. Intensity proportional to what? Square of amplitude, same waves. Here in last chapter, first chapter you already studied waves. Now, these are physical optics, what we study now. Here light rays are nothing but what? Electromagnetic waves, same characteristics of waves, everything same, sound waves and light waves. Now, here intensity is proportional to what? Square of amplitude. Now, I proportional to a square. Now, a square how much? Root will get cancelled. I proportional to what we are getting? A square plus b square plus 2ab cos pi. Now, when condition for constructive interference of waves, already explained constructive interference. How constructive interference takes place? Crest of one wave. Here, crest of one wave overlaps the crest of other wave, or trough of one wave overlaps the trough of other wave. On the time those are in phase. So, on the time amplitude is maximum, but mathematically we explain like this. For constructive interference, I should be maximum, which is possible only if cos pi is maximum. Here, what is maximum value of cos pi? 1. Cos 0 is 1. Cos value varies from what? -1 to +1. Now, here when amplitude will be, intensity will be maximum, here constructive interference means what? Bright band will form. Constructive interference means what? Bright band will form. So, intensity is maximum. When intensity is maximum, cos pi value must be maximum. What is maximum value of cos? 1. For which angle? 0 degrees. So, that is why pi value how much? 0, otherwise 2 pi, 0, 2 pi, 4 pi. If you take 0, cos 0 how much? 1, cos 2 pi 0, cos 4 pi 0, cos 6 pi 0, cos 0. Cos 0 how much? 1. Here cos 0 is 1, cos 2 pi, cos 360 also 1, cos 460, cos 360 is 1, 360 plus 0, cos 0, again 720 also, cos 720 how much? 0, cos 0, cos 0 is 1, like that. So, for maximum value of cos is 1. So, for what is phase difference here? 2n pi, phase difference is 2n pi, n is equal to what? 0, 1, 2, 3 and so on. Corresponding path difference, you know that phase difference is equal to what? 2 pi by lambda into path difference. In waves you already studied phase difference, we have relation, what is that? Phase difference is equal to 2 pi by lambda into path difference. Now, phase difference is equal to 2 pi by lambda into path difference, like that. Now, what we take now? This is delta pi is equal to 2 pi by lambda into delta x, path difference. Now, phase difference how much we have? 2n pi. Now, from this delta x is equal to what we write? Lambda by 2 pi into delta pi, that only written here. Now, here lambda by 2 pi into delta pi how much we got? 2n pi. Now, 2 pi gets cancelled. Now, delta x is equal to what? N lambda, that only there here. If the path difference is n lambda, we are getting constructive interference, intensity is maximum. So, bright band will form. So, actually physical interpretation, what is that? Crust of one wave overlaps the crust of other wave, or trough of one wave overlaps the trough of other wave. So, bright band will form, constructive interference takes place. So, delta is equal to what here? Path difference is equal to n lambda, n value almost 0, 1, 2, 3 like that. And so, why we are taking 0? First of all, we are getting maximum, central maximum, n is equal to 1. N is equal to 1 means what? 2 pi, next bright band. N is equal to 2, next bright band, like that. We are getting bright band number of times. So, first bright band 0 degrees, second bright band 2 pi, n is equal to 1, 2 pi, next bright band 4 pi, like that. Now, intensity becomes what? Cos 0 is 1, a plus b whole square, I maximum proportional to what? A plus b whole square, I maximum proportional to how much? A plus b whole square. Next one, condition for destructive interference. How destructive interference takes place? Crust of one wave overlaps the trough of other wave. So, on that time those two are out of phase. So, intensity is minimum. So, that is called destructive interference. Now, what is the minimum value of cos from this formula? Here I is equal to what? I proportional to what? A square plus b square plus 2ab cos pi. When intensity is minimum, cos pi is minimum. What is minimum value of cos? Minus 1. For which angle? 180 degrees. Cos 180 is minus 1. So, we substitute now. Here pi is equal to what we take? 2n plus 1 into pi. Here n is equal to 0, we substitute. What we are getting? Pi. Cos pi is minus 1. So, cos pi is minus 1 for which angle? Pi. So, that is why we write 2n plus 1 pi. So, n value of 0, 1, 2, 3 and so on. So, on that time same thing. Here we are getting destructive interference, path difference how much? Delta represents what? Path difference. 2n plus 1 into lambda by 2. 2n plus 1 into lambda by 2. So, I minimum proportional to what? A minus b whole square. I maximum proportional to what? A plus b whole square. What are AB? AB are amplitudes of two waves. Amplitudes of two waves. Here I maximum proportional to A plus b whole square. I minimum proportional to what? A minus b whole square. Like that. Next one. So, comparison of intensities of maxima and minima. I maximum proportional to what? A plus b whole square. I minimum proportional to what? A minus b whole square. I maximum by I minimum. A plus b whole square by A minus b whole square. So, what we write now? Numerator divided with b, numerator and denominator divided with b square. So, what we are getting now? A by b plus 1 whole square, A by b minus 1 whole square. Now, ratio of amplitudes we take R. Now, I maximum by I minimum how much? R plus 1 by R minus 1 whole square. R plus 1 by r minus 1 whole square. This is the ratio of maximum and minimum intensities. Next one, we have relation between intensity amplitude of the wave and width of the slit. Here I proportional to a square. Already you studied in waves chapter. Intensity proportional to what? Square of amplitude. Amplitude proportional to what? Square root of width. That's why intensity proportional to what we write? Intensity is equal to what? I1 by I2 is equal to what we write? A1 by A2 whole square and also W1 by W2. But A1 square is equal to what? A1 square proportional to what? Omega W. What is W? Width of the here, width of the slit. That's why I1 by I2 is equal to what? W1 by W2 or A1 by A2 whole square. Anyhow, intensity proportional to what? Square of amplitude. That is the relation between intensity amplitude. Intensity, amplitude and width of the slit, like that. Next one, already I told this. Now we calculate back. Now we have fringe width. Next we have fringe width. Is it clear? Now fringe width. What is fringe width? Here, distance between adjacent or successive bright bands or dark bands. Here on the screen we have bright band, dark band, bright band, dark band, bright band, dark band, like that. Now here distance between successive bright bands or dark bands. Distance between successive bright bands or dark bands is called what? Fringe width. Now for this path difference, we derive expression for fringe width. Now here suppose now just we draw equivalent diagram for this Young's double slit experiment. We take two slits S1 and S2. Here we screen. Now suppose screen is at a distance d from the two slits and d, small d, with the distance between two slits. Small d with the distance between two slits. What are S1, S2? S1, S2 are two coherent sources. S is the source of light. Now S is the source of light. S1, S2 are two coherent sources. Small d is the distance between. Small d represents what? Distance between two sources. Capital D. What is capital D? Distance of the screen from the slits. Now here suppose from two slits we are getting two waves, from two sources we are getting two waves. Now reach the point P with some phase difference, hence path difference how much? What is path difference? Difference in paths. Difference in paths travelled by light waves reaching at one point. That is called what? Path difference. First wave how much distance travels? S1p. Distance travelled by the first wave how much? S1p. Distance travelled by the second wave how much? S2p. Path difference how much? S2p minus S1p. Path difference means what? Difference between the paths travelled by light waves. ఇక్కడ రెండు తరంగాలు ఒక పాయింట్ వద్దకు వచ్చినప్పుడు అవి ట్రావెల్ చేసే డిస్టెన్సెస్లో మధ్య దూరాన్నే మనం ఏమంటాం? మధ్యలో దాన్నే మనం పాత్ డిఫరెన్స్ అంటాం. అయితే ఇక్కడ ఈ S2p మైనస్ S1p అనేది ఏంటిది? పాత్ డిఫరెన్స్. ఇక్కడ మనం we derive expression for fringe width. So that's why first we calculate path difference. S2p minus S1p represents what? Path difference. First we calculate here S2p square minus S1p square value. Now S2p how much? Here S2p is hypotenuse. So S2p is equal to what we write now? D square plus y plus d by 2. Now here screen, the point P is at a distance y from the point P is at a distance y. O is the central maximum. Point P is at a distance y from central maximum. Now on that time S2p square is equal to what we write? D square plus y plus d by 2. D square plus here y plus d by 2. Here up to here only. So y plus d by 2. Y plus d by 2 whole square minus S1p. S1p how much again? Here d square. Base is same. Here height becomes what? Y minus d by 2 whole square. Y minus d by 2 whole square. Simplifying now, a square minus b square how much? A plus b into a minus b. According to that, S2p minus S1p into S2p plus S1p is equal to what? After simplifying, we are getting 2yd. Here minus is there. So d square plus y plus d by 2 whole square, a plus b whole square. We divide, this we simplify. Plus d square minus d square, everything will get cancelled. Finally, we are getting 2yd. 2yd. Now S2p minus S1p is into S2p plus S1p is equal to what we are getting? 2yd. Now S2p plus S1p. Here S2p plus S1p is equal to what we take? 2d. We are introducing negligible error. Here S2p plus S1p, d plus d 2d. Actually here we are introducing negligible error. So d minus d 0, but we are introducing negligible error. On that time only we calculate path difference. Assumption here, S2P plus S1P is equal to, we take 2D. Here S2P, S1P how much? Here we are considering approximately equal to 2D. We are introducing a negligible error. We are taking assumption on that time path difference is equal to what we are getting? YD by D. Path difference is equal to how much we got? YD by D. What is Y? Distance of the point from the central maximum. What is small d? Distance between two slits. What is capital D? Capital D represents what? Distance of the screen from the slits. Capital D represents what? Distance of the screen from the slits, like that. So, path difference is equal to what we got? Y into small d by capital D. Y into small d by capital D, like that. Next one. Here, positions of bright fringes. For a bright fringe at P, delta is equal to what we got? YD by D. For a bright fringe, here, for a bright fringe, what we are getting? Path difference how much? N lambda. N is equal to what? 0, 1, 2, 3. Now, Y is equal to what by formula? N lambda, here, ND lambda D by D. Here, N lambda, here, from this, what do we write now? Y is equal to N lambda, ND lambda by Y is equal to how much? N lambda capital D by D. For N is equal to 0, Y is equal to what? 0. N is equal to 1. N is equal to 1, what we are getting? Y1 is equal to what? D lambda by D. N is equal to 2, Y2 is equal to 2 lambda D by D. Now, N is equal to 3, Y is equal, for N is equal to N, we take what we are getting? ND lambda by D. For dark fringe, positions of dark fringe, now how much we got path difference? Here, for constructive interference, dark band, what is that? 2n plus 1 into lambda by 2. So, you must remember here condition for constructive and destructive interference. You must remember all values, path difference, phase difference values for constructive and destructive interference on the time for dark fringe, how much? 2n plus 1 into lambda by 2. 2n plus 1 into lambda by 2, n is equal to 0, 1, 2, 3. First n is equal to 0, we are getting d lambda by 2d. N is equal to 1, we substitute 2 plus 1, 3. 3 d lambda by 2d. N is equal to 2, 2 plus 2 into 2, 4. 4 plus 1, 5. 5 lambda d by d, like that. Now, here expression for dark fringe. Here actually it is not dark, it is bright. It is bright only. Here expression for bright fringe width. Fringe width means what? Distance between, here this is dark. Now, expression for bright fringe width. Here what is fringe width? Distance between successive bright bands. What is fringe width? Distance between adjacent bright bands. So, for bright bands how much? Yn minus 1. Now, for n band how much? For nth band n d lambda by d minus n minus 1 d lambda by d. We are differentiating. What we are getting? 2 minus 1, 1 lambda d by d only. Lambda d by d. Y1 minus y0 how much? Lambda d by d. 2 lambda d by d minus d lambda by d how much? Lambda d by d. Like that. For n and we calculate difference between nth band and n minus 1th band. We are getting how much? Lambda d by d. What is d? D is the distance of the screen from the slits lambda wavelength. Small d, distance between the screens. Here dark bands. For dark bands also, here 3 minus 2, 3 minus 1 how much? 2. 2 gets cancelled, lambda d by d. Like that, we calculate 2n plus 1 band and 2n minus 1th band, 2 into n minus 1 band, we are getting lambda d by d, d lambda d by d. Like that. The expression for fringe will show the fringes are equally spaced on the screen. So, dark band and bright band occupy same space. Fringe width between, distance between successive bright bands we got d lambda by d. Successive dark bands also how much we got? D lambda by d. So, space occupied by the bright bands and dark bands are same. Space occupied by the bright bands and dark bands are same. Now, anyhow, we got fringe width how much? Fringe width is equal to lambda d by d. Fringe width is equal to how much? What is definition of fringe width? Distance between successive bright bands or dark bands. How it is represented? It is represented by beta. Beta is equal to d lambda by d. D lambda by d. Here suppose if capital D and small d are constant, beta proportional to lambda. Here lambda and small d are constant, beta proportional to capital D. Like that. Here lambda varies, here beta varies, like that. And next one, we suppose if the experiment is doing in a medium, On that time wavelength value changes, lambda value becomes what? Lambda by mu. Now in air or vacuum, beta is equal to what? Lambda d by d. Beta is equal to how much? Lambda d by d. In a medium, suppose if the experiment is doing in one experiment, fringe width, later we discuss that. If the experiment is doing in a medium, if the experiment is doing in a medium of a liquid medium, on that time beta becomes what? D lambda, beta medium is equal to what? Lambda medium by d. Lambda medium by d. On that time lambda medium how much is equal to what we write? Mu is equal to what we write? Mu is equal to lambda medium in air by lambda medium, like that. So on that time lambda medium is equal to what? Lambda by mu. Lambda by mu. On that time here beta medium is equal to how much? D into lambda by mu into d. So it is nothing but what? Beta by mu. B medium is equal to what? Beta by mu. Fringe width value, here fringe width decreases. Beta by mu. Beta is the fringe width in air medium. Beta is the fringe width in air medium. Beta m is the fringe width in medium of refractive index mu. On that time B medium is equal to beta medium becomes what? B by mu. Why? Wavelength changes. Wavelength of light in a medium of much? Lambda air by lambda mu. Now we are getting beta by mu. Beta by mu, like that. And now we discuss distribution of intensity. Distribution of intensity. So suppose here the two interfering waves have same amplitude, say A. A is equal to B is equal to what? A only. On that time I maximum proportional what? A plus B whole square. B is also equal to what? A plus A. Now here A plus A whole square. A plus A how much? A plus A how much? 2A. 2A whole square how much? 4A square. I maximum proportional to what? 4A square. All the bright fringes have same intensity. Now everything at central maximum we are getting first bright band. Here central maximum, this is first bright band, second bright band, third bright band. Here all bright bands having same intensity. How much? Here 4A square. Here mean dark bands when we are getting bright bands, crest of one wave overlaps the crest of other wave, or trough of one wave overlaps the trough of other wave, bright bands will form. So all are having maximum intensity. Destructive interference, dark band means what? Those two are out of phase. Crest of one wave overlaps the trough of other wave. Here amplitude becomes what? 0 here, 0, like this. These are dark bands. I minimum is equal to what? 0. All dark fringes have 0 intensity, like that. A minus A, here A minus A how much? 0. So amplitude is 0, intensity is 0, like that. Condition for sustained interference. What are that? Two sources producing interference must be coherent. When interference takes place, these two sources must be coherent. And the two interfering wave trains must have same plane of polarization. Polarization next I explain. Now here the two sources must very close to each other, and the pattern must be observed at a larger distance, have sufficient width of the fringe. Here the two sources must be very close to each other. What is in Young's double slit experiment? Distance between two slits how much? Small d. Small d is distance between two slits, that must be less, and here screen must be far. Here screen, that pattern must be observed at a larger distance to have sufficient width of the fringe. So lambda d by d. Here the source must be monochromatic, otherwise the fringes of different colors will overlap. Here monochromatic means what? White light. Here the sources must be monochromatic. Monochromatic means what? White light. ఏకవర్ణ కాంతి జనకం. ఇక్కడ సోర్సెస్ అన్ని మనకు ఇక్కడ సోర్స్ అనేది ఏకవర్ణ కాంతి జనకం కావాలి, అప్పుడే మనకు వస్తుంది. అదే లేకపోతే మనకు వేరే కలర్స్ తీసుకుంటే అన్ని డిఫరెంట్ కలర్స్ ఏమవుతాయి? ఓవర్లాప్ అవుతాయి. And the two waves must be same amplitude for better contrast between bright and dark fringes. If we are getting two having more equal amplitudes, we are getting maximum amplitude, maximum intensity. That's why here the two waves must be having same amplitude for better contrast between bright and dark fringes. If they do two having equal amplitude, intensity amplitude becomes what? Resultant amplitude becomes 0, resultant intensity becomes what? 0. If two waves, if we are taking two waves having same amplitude, on the time only we understand the here better contrast between what? Bright bands and dark bands. If we take two waves of same amplitude, so amplitude is maximum, we are getting bright band, and in case of constructive interference we are getting maximum intensity. Destructive interference we are getting two are same amplitude, we are getting amplitude is 0, resultant amplitude is 0, intensity is 0. So that's why for better contrast between the bright and dark fringes. So, what we take now? The two waves must be having what? Same amplitude, must be same amplitude. Here already we calculate resultant amplitude. How much we got? Amplitude is equal to how much we got? Here A is equal to under root of A square plus B square plus 2AB cos pi. 2AB cos pi. What is pi? Phase difference. On the time A square is equal to how much? A square is equal to A square plus B square plus 2AB cos pi. Here already I told that for better contrast amplitudes must be equal. Amplitudes must be equal. A is equal to B. So, we write what we write now? B is also equal to what we write? A. So, A square plus 2 into A cos pi. From this A square is equal to how much we are getting now? A square plus A square 2A square plus 2A square cos pi. 2A square cos pi. From this A square is equal to, we take 2A square common. How much we are getting? 1 plus cos pi. 1 plus cos pi how much? 2 cos square pi by 2. In trigonometry you already studied. A square is equal to what we write? A square is equal to 2A square into 1 plus cos pi how much? 2 cos square pi by 2. 2 cos square pi by 2. So, from this A square is equal to 4A square. A square is equal to what we write? 4A square cos square pi by 2. 4A square cos square pi by 2. Now, multiplying k on both sides, Ka square is equal to what we are getting? 4 into Ka square into cos square pi by 2. From this, here intensity proportional to what? Square of amplitude. Here I proportional to what we write? A square. So, I is equal to what we write now? Ka square. Suppose I naught be the intensity of one wave. So, I naught proportional to A square. I naught is equal to what we write? Ka square. From this, here intensity, resultant intensity I is equal to what we write? 4 into I naught into cos square pi by 2. Here resultant intensity, what is formula? I is equal to 4 I naught cos square pi by 2 at central maximum. Here pi value how much for constructive interference? Pi is 0. Now, pi is equal to 0, 0, 2 pi, 4 pi like that. So, intensity becomes what? 4 I naught into cos 0. Cos 0 how much? Cos square 0. Cos 0 is 1. So, we are getting 4 I naught into 1. So, what we are getting now? Maximum intensity, intensity of central bright fringe. How much? I maximum is equal to 4 I naught. I maximum how much? 4 I naught. Here, remember this formula, intensity in Young's double slit experiment, what is resultant intensity? 4 I naught cos square pi by 2. 4 I naught cos square pi by 2. Actually, suppose I naught be the intensity of one wave. Now, two waves are superimposed. On that time, intensity becomes what? Here 4 I naught, bright band. Here for a bright band, intensity becomes what? 4 I naught. Here, what happened? Here constructive interference, crest of one wave overlaps the crest of other wave, or trough of one wave overlaps the trough of other wave, intensity will be maximum. So, maximum intensity how much? 4 I naught. And for destructive interference, what happened? Here pi value how much? Pi value is pi. Here for minimum value, for first of all you remember this intensity of a resultant wave in interference in Young's double slit experiment. What is formula? 4 I naught cos square pi by 2. 4 I naught cos square pi by 2. What is pi? Phase difference between the waves. What is I naught? I naught is the intensity of one wave. So, maximum intensity how much? 4 I naught. Maximum intensity is 4 I naught, and minimum intensity. Is it clear now? Now, and also what we write now? Here we write formula for resultant intensity. We write formula for resultant intensity. Here now squaring both sides. A square is equal to what we are getting? A square plus B square plus 2AB cos pi. 2AB cos pi. On that time, suppose intensity I is equal to what we write now? The intensity of first wave is we are taking I1 plus I2 into 2 root I1, 2 root I2 cos pi, like that. Here intensity proportional to what? Square of amplitude. Now, we multiplying k on both sides. So, what we write now? Resultant intensity is equal to what we write? I1 plus I2 plus 2 root I1 I2 cos pi. 2 root I1 I2 cos pi. Maximum intensity how much now? If pi is equal to 0, maximum intensity how much? I maximum is equal to I1 plus I2 plus 2 root I1 I2 cos 0. Cos 0 how much? 1. So, I maximum is equal to I1 plus I2 plus 2 root I1 I2. 2 root I1 I2 cos 0 how much? 1. So, what we write now? I maximum is equal to what do we write now? Root I1 plus root I2 whole square. Here I maximum is equal to what we write now? Root I1 plus root I2 whole square. Root I1 plus root I2 whole square. In the same way, for dark band, here, when we are using this formula, what is difference between these two? This is maximum intensity. Maximum intensity when two waves having same amplitude. Two waves having same amplitude, same intensity, maximum intensity how much? 4 I0. But two waves having different intensities, what is formula for maximum intensity? Root I1 plus root I2 whole square. In the same way, we calculate minimum intensity. For minimum intensity, what we take? You remember this maximum intensity, what is formula? Root I1 plus root I2 whole square. Root I1 plus root I2 whole square. And minimum intensity means what? Theta pi value how much? Pi 180 degrees out of phase. Now what we are getting now? Minimum intensity. Here I minimum, from this I minimum is equal to what we are getting? I1 plus I2 2 root I1 I2 cos pi. Cos pi how much? Minus 1. So I minimum is equal to I1 plus I2. Here cos pi how much? Minus 1. So 2 root I1 I2 minus 1. So from this I minimum is equal to I1 plus I2 minus 2 root I1 I2. So what we write now? I minimum is equal to I1 plus I2 root I1 minus root I2. Root I1 minus root I2 whole square. A minus B whole square. A minus B whole square how much? A square plus B square minus 2AB. So I minimum how much? Root I1 minus I2 whole square. If I1 is equal to I2, I minimum becomes what? 0. This is for maximum intensity, this is for minimum intensity. When two waves are having different intensities, different amplitudes.